Good morning everyone, so we're from the group called Cone and Frustum. So my name is Barbara and this is Hui Teng, MC, Karen, Christine and also Kwang Zhou. So, so we're going to talk about cone and frustum. So what is cone? Basically a cone is a 3D geometric shape which consists a circle shape as the base and also a curved side ending up with a tip called apex or vertex. So the cones are divided into two categories, which is right circular cone and also the oblique cone. So what's the difference between the right circular cone and the oblique cone is the angle. As you guys can see, the apex, the right circular apex is positioned right in the center point, while for the oblique cone is not positioned on the center point. So which means the right circular cone's angle between the lateral surface and also the base is the same, while the oblique cone angle between the lateral surface and the base are not the same. Next. So moving on, what is frustum? A frustum is created by slicing off a cone. This is cone, so after you slice it, it's frustum. So cone, frustum, cone. Yeah.
So this is a cone, and you cut it half in frustum. So here's the question in time. When you cut it in this way, is it a cone above, or is it a frustum at the bottom? Not hard. It's easy. Actually, it's not, because the definition is a cone. The base must be circular shape. Once you cut this way, it's not circular shape, so it's not a cone. And the other question, if you cut it this way, is it a cone? Half cone. No, because the base is not still circular shape. Okay, so when this is the cone, here is the radius, here is the diameter, and this is the height. And this is also the same, but the difference between the cone and the frustum is the cone has one circular base and the frustum has two circular base. So next. So the cone has many types. As long as it has a circular shape and it is covered by the curve, and there's only one vertex, the sharp thing. So next. And the frustum have the two circular base and covered with the height, and that's all. The special thing is it is covered by the L, which is the curved side cover around the frustum. So same the radius and the height, the L.
So now I'm going to talk about the volume of a cone. The volume of a cone is defined as number of cubic units that will exactly fill a cone. So in a cylindrical shape, that means that it has 3 cones. It can fill in 3 cones in one. Therefore, the volume of the cone is developed from the volume of the cylinder, which is 1/3 pi r square h, where r equals to the radius and h equals to the height.
So I'll be talking about the surface area of cone. The formula of surface area of cone is pi r s plus pi r squared. Pi r s is actually the curved surface area, and r is radius, s is the slanted part which comes from the right angle triangle. And pi r squared is the area of the circle, and then add up the curved surface area and the surface area of the circle, and you will find total surface area of cone.
Okay, I'm talking about the volume of frustum. Let's start from a cone. You see, this is a cone. When cut into half, the upper part will become the cone, a smaller cone, and the bottom part will become the frustum. So the volume of frustum will be equal to the volume of the entire cone and deduct the thick cone. So it will become the volume of the frustum. So from this formula, we have two H. The H of the thick cone and the H of the frustum. So, but normally we will be given only a H. So I will further explain about the formula. Okay, so this is a cone, and when I cut it in half, this is a section. So the line above will be the diameter of the thick cone, and the bottom will be the diameter of the base cone. So I cut it into half, it will become like this. So this two will become the radius of this two. Okay, so when it becomes like this two is parallel. So how many triangles do you see in this figure? Two, right? The small one and the big one. So these two triangles is similar because they share a same angle, and this two is parallel. So these two angles is same, and these two angles is same. Okay, so these two triangles, the small one and the big one is similar. So I get this, the ratio of the length of the side. So by arrange this, I get two equations. When I substitute these two equations into the okay, when I substitute the two equations into this formula, which is the volume of the entire cone deduct the volume of the thick cone, I will get this formula. So by using this formula, I don't need to have this H in order to get the volume of the frustum. So this is the example of the frustum, calculation of the volume of frustum. So I only need to have the radius, the upper radius and the base radius, and the height to get the volume of the frustum.
Okay, so I'm in charge of the surface area of the frustum. So in case you don't know yet, it's actually minus the tip of the cone and become like this. The frustum actually look like this. So basically the surface area of frustum is consists of a few formula. Okay, the first one, S. Which one is S? Which is this, the slanted line. Okay, the length of the slanted line is this formula. Okay, so I've written down it here, so after I will explain further. Okay, so, and then, okay, the next term is lateral surface area. What is lateral surface area? Which means the red color of surface area. It's lateral without the two circular area. It's called lateral surface area. So, lateral surface area, which is the red color one, is written as this. Okay, so it's basically this one and then multiplied by S, which is the previous formula. Next. Okay, and then when you combine everything together, which is the total surface area, you put the lateral surface area in front, and then behind you combine the top circular surface area and the bottom circular surface area. So, Zhao Wei, what is the formula of the area of the circle? Circle. Yeah, correct. So it's simple. Pi r squared. So you just basically plus top and bottom. Easy, right? Okay. So now let's look at it. I've written out everything. So it's basically S is the slanted area. Then the lateral surface area is this formula multiplied by the slanted area. So when you break everything down, it will become like this. The total surface area, which is this one is the lateral, multiplied by the slanted area, which is this one here, and plus the top area and the bottom circular area, which is pi r squared. Okay, so I guess it's very easy. So let's find someone to do some questions. Okay. Okay, so I need a person to look for the lateral surface area of this. Okay, never mind. You can take your calculator. You need the calculator. Okay, so lateral surface area. Do you know what is lateral surface area?
Yeah, the red one. The other circle.
Okay, yeah. So look for the lateral surface area. Okay. This is the area of the lateral surface area.
Okay. This question is
Yeah.
5, 8.
Okay, this is the length of the slanted area.
I got it. So, plus root 8 squared plus 100 equals pi 8 square root of pi 64.
Sorry, this is minus.
Oh, okay. 4.
It's wrong, you know why? You know why it's wrong? Because actually it's R1 minus R2. R1 is this one and R2 is this one. So it, yeah. Then yeah, I know. I mean your.
Oh yeah. Right.
Yeah, right. Then the answer.
What's that?
Yeah, it's correct. It's correct. Continue.
Correct. Okay.
Fast lah.
10.7.
Yeah, correct. Okay, no, so now I want to demonstrate another form of fraction that is also possible. Which is Yoni. Calculator. So what is the difference between the first question and second question is the first question is more directed because it's given the height. But now the second question is not so directed because it gives you the slanted height. Total surface area. This one is total. First is height. But here we are given so basically you see the slanted height is given, right? So you write 15 in the first, and then you need to find for this the height, which is h. So the answer could be found through this equation.
Okay, it's okay. Okay, basically you left out one very important thing, which is okay, so basically that one is the correct answer for the height. So now once you got the height, you can proceed to the total surface area.
Finish this until this.
Because of the time, yeah, the procedure is correct, and the answer is 10. But then actually it can be simplified. You don't need to write so long because you can use the lateral surface area, which is much more easier. So after you found the height, then you can proceed to the next, which is the lateral surface area, and then it goes like this, which is lateral surface area. Okay, so when you got the lateral surface area, you just substitute this one. Yeah, you just substitute. Instead of writing so long and then you got confused, you can do it the simple way, step by step. If you are not a genius, so just do it. Yeah, for me, I prefer this way, so you can just simplify everything. So this one becomes. And the answer is so you guys understand? Any question about this?
Why the first formula S equals to square root R
Because when you do logic, it will become a vector or theorem. Okay, this will become R minus R, and this will become the H, and this will be the height. Yeah.
So for the formula for S, right, is really simple. It is just refers to the right angle triangle that we just developed, right? So that's why the bottom, the horizontal line is actually R2 minus R1 or R1 minus R2. They are the same, right? And then you solve it by using Pythagorean theorem, right? Okay. Any other question? That's all. Okay. Okay, here, if you look at the definition right? With a circular base, does it necessarily to be a full circle? No. For a cone.
Yes.
Does the base have to be exactly a circle?
Yes.
In fact,
No.
sometimes we will have the base has ellipse. No ellipse, right? Oval. Alright, and then you have a lateral surface area which meet at one particular point. That one we consider it is a cone as well. Alright? So if you want to calculate the area, the volume for the ellipse cone, it will be the same, which is the volume of a cone. Which is
1/3 times the base area and height.
1/3 times
The base area
and
and height.
Can you please write down the volume of a cone? Is equal to base area. So what about an oblique cone?
It's the same.
Yes, it's the same, right? The height will be the perpendicular height. It is not the slanted height. Right? Okay, just one more thing about what I think Kwang Zhou was saying just now. If you have a cone, a full circle cone, when you chop it off slanted, the top part, whether it is still considered as a cone, right? That's your question to them just now, isn't it? And then the bottom part is still considered as a frustum or not? And your answer is saying no, right?
Actually, the upper part will become an oblique cone.
Yes, exactly. That's the point. In fact, if you chop it off slanted, the top, the smaller tip, in fact, it is still a cone. But the base is no longer a circle. It becomes an ellipse. Yes. It becomes an ellipse. Can you imagine that? You have a cone, you chop it off slanted, what happens on the top part? In fact, the base is become an ellipse. And when you put the flat surface on the table, you can notice that the tip is actually away from the center of the base. So that one is actually an oblique with an ellipse base. Got it? Alright? And then the bottom part is not considered